In our previous session, we have created a LangChain framework and we integrated it with a MySQL database and a streamlined chat interface. We asked many natural language questions and it fetched the data from the MySQL database and provided as a tabular data format. But the problem is, LangChain framework is pretty much complex. Why can't we leverage the simplicity of LangGraph? In the LangGraph, we have nodes so that the complex LangChain frameworks can be broken into small microservices and that can be assigned to the respective nodes. These nodes together can be connected using edges so that our complex workflow will become a very plain and simple workflow. Remember, we should know how to pass the input, where to take the output, and how to assign the output of one state to the another node. The state is as simple as like a snapshot of the node. It contains both input and output. So the way it works is we have the starting of a workflow. In the starting of workflow, we'll be assigning one input to the first node, then it will process it and it will pass the output to the second node. That output will be getting treated like an input of this node and it will be processing it further. So a number of nodes will be involved and finally we will be getting the output. So the life is much more simpler and it is so easy for us to troubleshoot as well. And since it is an automated process, we should be very clear and careful that what we are passing as an input and what we would be getting as an output. For that, we can use a schema-based input-output mechanism. We would be discussing about input and output pertaining to a LangGraph workflow. Apparently, we will streamline the existing LangChain framework in line with the LangGraph workflow. This is Melvin Satishan, and without wasting much time, let's move on to the workshop. Let us open a Python notebook. Here we have Python 3.9.6. Let's import the necessary Python modules from LangGraph.graph, import state graph and end. Next, we need to import from typing, import typed dict. Finally, to visualize our workflow, from ipython.display, import display and image. So these are the necessary Python modules. Next, we have to create input and output schemas. Class input node A, any name you can define it here, and it is going to be typed dictionary. And let's say name is going to be string. Our node A input is ready. Next, class output underscore node underscore A is again going to be typed dictionary, and we will define name is going to be string and age is going to be integer and location is going to be string. Okay, so these three parameters to be provided. Finally, class output, let's say output not B, typed dictionary, and it should contain name is equal to string and age is equal to integer and location is again string, category equal to string. Okay, let's understand what we have defined here. We would be providing an input as a name dictionary, then the node A will process it. It will provide us name, age and the location of the candidate. Then it will provide a dictionary which contains these three elements. That output of node A, we will pass it to node B. Then the node B will process that input and it will provide us another dictionary as output, which contains name, age, location, and category. Okay, so our input and output schema is ready. Now it's time to create the nodes. Nodes are the functions or runnables pertain to a LangGraph workflow. Let's define node underscore a. Here state is going to be input node A, because it will accept the input as node A and it will take the output node A. It will provide us the output, right? First thing, print f string the state of the node A is, here we will define state. Next, output equal to, here we have to define name, and in the name we have already defined in the state so that it is visible there, name. Next, age, in this case we have to define it manually. Let's define 2, and location, we don't have any value now, we have to define the hardcode values. Next, return the output so that it is going to assign back to node A. So the node A output is ready, which is this output is aligned with this output node A schema. Let's execute this. Next, we have to create the node B. Define node B. Here it is going to take a state, and the input is going to be output of node A, because this output or this value we are going to be passed to the node B, and it is expected to provide us the output of node B. And the output of node B, before we define it, print f string the state of node B is state. Okay, now output equal to, inside the dictionary again, name, state, name, we have defined it. Next is age, state and age. Third is going to be location, so that is also available in the state. Perfect. The final thing is category. So we haven't defined anything, so we need to provide a manual value. Let's say minor, so category is minor. Next, return the value to the function. So that part also completed. We created the input and output schema. We created 2 nodes. Now it's a time to initialize our graph. State graph, and then bracket, we have to provide input. In our case, input is going to be input node A, and we have to define the output. Output is going to be output node B, because we are providing the input to the node A, and we will be getting, or the final output must be from the node B. So that we have defined it here. Perfect. Next part, we have to define the workflow arrangements. Let's do this way. Builder dot add node. First, this is the alias of a node. I'm going to call the node A as A, and here the node function, we have to define it. First, node A, which is having the alias A, has been added to our workflow. Next is builder dot add node. Here the second node is going to be B, and I'll add it as node B. So the 2 nodes are added. Perfect. Now the workflow, we have 2 independent nodes, but we haven't connected it together, right? Let's do a connection part. For that, builder, here we go, A to B. This is the first connection, A to B. Next is builder dot added, then b to end, because we need to full stop it, right? Else it will execute unnecessarily. So we should define that this is the end of the workflow. We have a graph which is having 2 nodes, and we don't know where to give the input. For that, let's create an entry point. Builder dot set entry point. Our entry point is, or the input is going to create in the node A. Let's compile the graph so that our workflow will be correct. Graph equal to builder dot compile, and it is going to be here. We have another option, debug equal to true, if you want to see detailed traces of the execution. Our graph is ready. Perfect. Now if you want to visualize it, we have an option, display display, and inside that, in bracket image, and again in bracket image, graph dot get graph method, and it's going to be a method, so that we have to put the bracket. And here we have something called draw mermaid png method. If you look at it, here we have a graph. It starts at node A and it ends at the node B, and it is connected together using edges. Perfect. How do we execute it? So graph dot invoke, as you know, it's going to be a typed dictionary, and dictionary should have only one key value, that's called name. Let's define a name here. I'm going to mention here Shreyan. If you look at it, it accepts the state name Shreyan as input to the node 1. Then it added the necessary parameters when it finished age and the location, right? Then that parameter we added to the next step, in the sense node B, which contains age, location and name. Finally, the node B has added an additional parameters, and it provided us the output. If you look at it, this is the output which we have received it. So altogether, let's execute this once again. Rather, I'll mention false. Okay. Here, the state of the node A is name Shreyan, which we have provided the input, and the state of node B is name Shreyan, age and location. These 4 parameters added in the output of node B. This way, the input and output mechanisms work in a LangGraph. This is the basic logic, so we can create the complex workflows, and we can create the schemas and pass the input and output accordingly. That's it for now, and we will see you in the next video. Melvin Satishan is signing off and wishing you a great rest of the day. Thank you.